Hello class, welcome to another class. So we're going to be working on parallel lines and applying them to similar triangles. So as usual, please copy this down. If you're using the printed version, then obviously you may use that. You don't need to copy it because it's already there. But what you do need to do is, regardless, fill this part out. Tell me, why do you think I chose this word? This word is 平行. It means parallel, or it could also mean of the same type of thing. So not necessarily just a math word, but there are quite a few words in Chinese that we use both for math and for regular things. So take a bit of time to do that. And then I'm going to assume you've paused and guessed in 3, 2, 1, 0. Okay. So just remember, class, I do check for that. Don't put because he wants to teach us Chinese. You will get marked off for that. Alright, so now let's look over here. So, just to remind us a bit, AA, SSS, SAS. AA means angle, angle. So that means two angles are congruent. SSS, that means side. So we have angles and sides. So SSS means three sides are proportional. SAS means a side, angle in between, and then a side. So side, angle, side. Angle is angle, angle. SSS, side, side, side. So just keep that in mind as we do this. So, let's look at this thing and try to see, well, what in the world is happening here. So, we're going to use parallel line relationships and proportions. So, we're going to use things related to, this is going to be related to angles, and this is going to be related to sides. So, let's look at what information we're given here already. We have two triangles. We can see, well, there's this angle that we can already conclude is the same because they share the same angle. So, information. Angle CAE is congruent to angle BAD because they are a shared angle. So shared angle just means that they both have it in common. Well, what else do we know? Actually, we can number these. That way when we refer to them, then we can use that for evidence. Okay, so we see BD and CE are actually parallel. Alright, we can actually use that information. So, let's extend this and look at it like parallel lines. So if we were to do that, let's see what that would be for this. BC. Well, some information that we have is this and this are congruent. I'm going to do 2 marks. This one's going to be 1. So, because BD and CE are parallel, we can conclude that angle ABD is congruent to angle ACE because they are corresponding angles. You can write it that way, corresponding angles. Okay, so do we need any other information? Actually, no. Because, so now you can write because angle CAE is congruent to angle BAB, and angle ABD is congruent to angle ACE. Therefore, triangle. Okay, so we can use whatever order we want. I'll just do ACE. Is similar to triangle, so that'd be ABD by SS triangle similarity theorem. And you can write theorem as THM. I'm just going to do them all uppercase. Alright, if you need this, pause, then move on. Alright, let's look at this. Oh, I meant to make this parallel. So add that in real quick. And if you have the printable version, easy, just do that. Alright, so let's see. What do we know? So this means that these two, so we know that AB is parallel to DE then. And let's see. This looks like regular parallel lines, so we can actually get a lot from this. If we look at this angle over here, that's an interior angle. This is an interior angle. It's an alternate interior angle. So we have that angle. I'm gonna do CAB. So that angle is congruent to that angle. So let's see, let's CED. Because they are, I'm gonna write this alternate interior angles just to save space. Well, what else can we do? Well, let's see. We can also do the same thing with these other two. But I also wanna, so you could do that, but I'm gonna review some other thing real quick over in the center. How about this? ACB. Angle ACB is congruent to what? It's congruent to this angle. I'm gonna call that angle probably ECD, because they are vertical angles. So we could also get that those other two angles are congruent. So if you notice that, great, you can write that as well. But this is actually all the information that we need. So you can write therefore triangle, I don't know, I guess ACB is congruent to, okay, so what is A congruent to? A is congruent to E, A, E. So remember, we have to match those. C is the next one there. So we have C. So that means this next one has to be C. And then the last one that remains is D. So from there, oh, that's interesting. Oh, that's why. Okay. By SS, you can do this for triangle. Similarity theorem. Sorry, that's AA. I don't know how I made that mistake. I am so sorry. If you caught that, great. Okay, let's go on over here. So now here, I want you to start writing down some of the information, And then I'm gonna pause so that you can work on that, and then assume that you've done that. And then we'll kind of go through the rest of the process together. All right. So write down any relationships that you see here based on parallel lines and or proportions. So please spend about 5 minutes to do that. And I'm going to move on with the video and assume that you've done that 5 minutes in 5, 4, 3, 2, 1, 0. Okay, so something you may have written down is that PQ is parallel to ST. So that's important, very important. So let's extend that real quick so that we can see things a little bit more easily in the way that we're used to. We'll leave that white line there. And then maybe we can do this. Use blue on one of the others. You don't need to color code it. This is just for me to teach you and make it a little bit easier that way. Well, what you might notice is, hey look, we have alternate interior angles again. Do you have to do that? No. Let's say angle RST is congruent to angle RQP because they are alternate interior angles. This time we can also do this, because why not? Angle STR is congruent to angle QPR, because actually for the same reason. They are alternate interior angles. So we already have two angles, but if you did want to again, you could get that fourth one. Angle TRS is congruent to angle PRQ. Because they are vertical angles. I'm going to do vert and then angles. Like that. Alright. Therefore, so remember the symbol means therefore. Triangle what is similar to triangle what? So take a quick second and do that real quick. I'm going to assume that you've written those three in 3, 2, 1, 0. So there's a few different ones that you could have written here. I probably would have just written PQR because alphabetic order on the left hand one. It doesn't really matter which order you choose. You could use QRP, RPQ, etc. Any of those orders works perfectly. RQP, same thing. So P, that is related to T. Q is S, and then R is itself. And here, we're able to do it again by angle, triangle similarity, theorem. So you're probably noticing that a lot of time when we have these vertical parallel lines, you're actually going to be using that specifically. Angle. We haven't actually used anything else yet. Keyword yet. So let's look at this one. Hey look, we have numbers now. Hint, we're going to be using some side stuff. So I'm going to give you a second to try that on your own. So take a few minutes, see what you might be able to do with the sides. And then we're going to move on in 5, 4, 3, 2, 1, 0. Okay. So, you might notice some things. For one thing, we know the XY is parallel to WR. Let's see, XY, WR. Are they related? Well, one of them is twice the other. How about, let's see, we have a 6 here. We have a 12. 12 is twice of 6. And then 10 is twice of 5. So we already do have that. We can say XY equals 2 times WR. And then let's say ZY is 2 times of ZW. And then we have, let's see, XZ is 2 times of RZ. Let's see what else we can get though. What other information can we get from this? So instead of just calling it there, because we could, but I also want to show us a few other things. So this is parallel. So we can do alternate interior angles again, like we've been doing forever. And then what else do we have? We also have the vertical angles. So I'm going to write down those relationships there. So we can do, let's see, angle XYZ is congruent to angle RWZ because they are alternate interior angles. And we can say the same thing about YXZ, congruent to angle, okay, so Y corresponds to W, WRZ, because, again, alternate interior. And then angle XZY is congruent to angle. X is the double one, so RZW, because they are vertical angles. So you have a few choices here. So if you notice now, we have a side, we have another side, as well as an angle. So side, angle, side. So you can say triangle XYZ is similar to triangle RWZ. By SAS, triangle similarity theorem. Or you have all three sides actually, so you can say by SSS, and if you can get two angles pretty easily, so AA works here also. So here you're given enough information to do all of those. All right, if you need to copy down, pause, copy. Here are the problems that I want you to do, so please copy these down, please start doing these, and submit those to Canvas. All right, have a great day, everybody.